Identify the points of discontinuity, the holes, the intercepts, and the horizontal asymptote and the domain. Goodness gracious me. All right, well, lots to answer. So I have myself a quadratic over a quadratic, and the first thing I want to do is factor the quadratics. So I'm going to do just that. Two numbers that add up to -1 multiply out to -6 are going to be -3 and 2. So the numerator factors out to that. The denominator, two numbers that add up to -2 and multiply out to -8 are -4 and 2. Oh, look, two 2's. Just like at a ballet recital. What am I doing first? Point of discontinuity. A point of discontinuity are the x values that if you were to plug into this equation, the whole thing, all right, would make it undefined. In other words, what numbers, if I were to plug into the bottom here, would give me a undefined equation? Well, if I were to plug in 4, and if I were to plug in -2, 4 would make this 4 minus 4, which makes that 0, which makes the whole thing 0, discontinuous. And if I were to plug in -2, same exact thing would happen. That is the zero product property in action. There's my points of discontinuity. A hole exists when you have a point of discontinuity existing in a parentheses. That's the exact same thing as you have there. So in this case, since I have an x plus 2 on the bottom and an x plus 2 on the top, my hole exists at -2. Okay, which means like if I were to graph this, there's not an asymptote happening. You just have a break in the graph. That's what a hole means. An intercept. Let's start out with the easy one, the y-intercept. And remember, you find the y-intercept by substituting 0 into your equation. So simply put, if I were to take f of 0 and plug in 0 for x, I would get 0 squared, which is 0, minus 0 minus 6, over 0 squared, which is 0 minus 2 times 0, which is 0 minus 8. And my y-intercept simplifies to -6 over -8, which is positive 3/4. That's my y-intercept. Now, the x-intercept is a little more involved. Okay, the x-intercept is what if I set my y, or my f of x, equal to 0. Okay, so let me not use red. I just used red. What color haven't I used? Black. X-intercept, I'm going to set my f of x equal to 0. So 0 equals x squared minus x minus 6 over x squared minus 2x minus 8. Now, what I'm going to do is I'm going to multiply both sides by this guy right here, which eliminates that entire thing. So now I'm left with x squared minus x minus 6. Let's not forget that if I wanted to use zero product property and factor this guy out, x squared minus x minus 6 is x minus 3 and x plus 2, which means my x-intercept is going to be positive 3 and -2. Oh, but wait. X can't be -2 because it's discontinuous there. So my only x-intercept is going to happen at 3. So again, my x-intercept looks like it should appear at 2 places, but it's not allowed to be -2 because -2 is where my line is discontinuous. Last but not least, let's get a nice little orange color going on here. Last but not least, my domain. Let's get rid of the color palette. My domain, when graphing these things, is going to be everything but where this is discontinuous. So what I will say is my domain is going to be all real numbers, but x cannot equal 4 and x cannot equal negative 2. Where did I get 4 and negative 2 from? Well, that's where my graph was discontinuous. So my domain says I'm allowed to plug in all real numbers except for 4 and negative 2. So lots going on there. But there you have it. I think I covered everything.